All right, guys, let's go ahead and get started. So we're going to go ahead and solve this polynomial, 10x squared plus 21x minus 10 equals 0. So to get started, we look for a GCF between all three terms. And there is no GCF besides 1, so we're going to go ahead and start by taking our a value and multiplying it by our c value. So 10 times negative 10 will give us negative 100. And at this point, we're going to go ahead and look for numbers that add to be 21, our middle term, and multiply to be negative 100. So we're going to list out all the factors of negative 100. So we have all of our factors over here, and the only ones that add to be positive 21 are negative 4 and 25. Well, you see 4 and negative 25 will get us negative 21, but again, we're looking for positive 21. So we have negative 4 and positive 25. From here, we're going to go ahead and put them in our double bubble. So we'll have x minus 4 times x plus 25 equals 0. Doing that will allow us to have our factoring. Now, we went ahead and we multiplied by 10 to get started. We need to undo that process. So we're actually going to divide by 10 now. So we're going to divide both bubbles by 10. That'll give us x minus 4 over 10 times x plus 25 over 10 equals 0. Reducing down our fractions, we get x minus 2/5 times x plus 5/2 equals 0. Now, if I'm solving, I can find out my answer just from this double bubble alone. However, I'm going to go through the entire process, so I'm going to factor and then solve. So to finish factoring, if it didn't divide evenly, I'm going to take my denominator and I'm going to move it in front of my x. And I do that for both bubbles. So if you have a denominator, move it in front of the x. That'll leave us with 5x minus 2 times 2x plus 5 equals 0. At this point, each parentheses gets its own equation. So I have 5x minus 2 equals 0, 2x plus 5 equals 0. So those are our two equations. Solving for x, we get x equals negative 5/2 and x equals 2/5. Now again, you can notice that these are just opposite values of whatever's inside our double bubbles up here. And that's why you can solve right away if you are solving. If you need to factor, though, you would need to factor down to this first. So just keep that in mind as you go through. And again, these are our two answers. X is equal to negative 5/2 and x is equal to 2/5. All right, so today we're going to be working on a right angle theorem. Our learning target is focusing on triangles. The depth of knowledge is a level 4. And what we'll be learning is, I know the definitions of altitude, median, and perpendicular bisector. So again, make sure that you guys are practicing these terms. You will see them quite a bit on the test. So to get started, we have our first theorem. This is our right angle theorem. It states, if two angles are both supplementary and congruent, then the angles are right angles. So if angle 1 is congruent to angle 2, then angle 1 and angle 2 are right angles. Now, for this, first off, I know that these angles are supplementary because they form a straight line, and I know that straight lines have 180 degrees. And by definition, supplementary angles are two angles whose sum is 180 degrees. So, if that's the case, if these angles are also congruent, that means out of these two congruent angles, so we have two congruent angles, and we can give 180 degrees to both of them. So 180 degrees per two congruent angles. Now, if we reduce this down, this will give me 90 degrees per one congruent angle. So that means that each angle here, each congruent angle that's shown, has to be 90 degrees, because it's 90 degrees per each congruent angle. So just keep that in mind. If you see angles that are not only supplementary, but also congruent, automatically they will be right angles. Let's go ahead and try and use this in a proof. So, given isosceles triangle ABC, and segment AD bisects angle BAC. So it's bisecting this angle up top. We want to prove that AD is perpendicular to BC. Now, first off, if this is the case, if we do prove that AD is perpendicular to BC, what would be a name for AD? Well, AD would then be an altitude, because I know that the altitude will be drawn from a vertex and intersect the opposite side at 90 degrees. Now, we're also going to see if this is going to be a perpendicular bisector, and we're also going to see if it's a median, but we'll determine that after this proof is finished. So to get started with this, of course, we're going to start by labeling out our given information. Triangle ABC is isosceles, and AD bisects angle BAC. That's both given to us. Now, focusing in on isosceles. If a triangle is isosceles, it has two congruent sides. So I can say segment AB is congruent to segment AC. And the reason that we can say that is if a triangle is isosceles, then two legs are congruent. From here, let's go ahead and focus in on bisections. So AD bisects angle BAC. If AD is bisecting that angle, that means angle BAD and angle CAD are being cut perfectly in half. So they're going to be congruent to each other. So we can now say that angle BAD is congruent to angle CAD because if an angle is bisected, then it is split into two congruent angles. So we now have a side and an angle. Lastly, there's a side that is shared by both triangles. So looking at both these triangles, they both share side length AD. So I can say that AD is congruent to itself, and of course that would be by the reflexive property. At this point, we should have enough information to prove that triangle BAD is congruent to triangle CAD. So triangle ABD, I'm just naming it a little bit differently, is congruent to triangle ACD by side, angle, side. So those two triangles are congruent by side, angle, side. Now, if the two triangles are congruent, then I know that angle ADB and ADC are also congruent. So angle ADB is congruent to angle ADC because if two triangles are congruent, which we see in statement number 6, then the corresponding parts of those congruent triangles are also congruent. So therefore, these two angles are congruent by CPCTC. Further, these two angles, angle ADB is supplementary to angle ADC. And the reason that we know that is because it's a pair of angles that form a straight line, meaning that these two angles are a linear pair. And I know that a linear pair is always going to be supplementary. Lastly, well, not quite lastly, since these angles are both congruent and supplementary, I can now say that angle ADB and angle ADC are right angles. Because if an angle is congruent and supplementary, then the angle is a right angle. Again, this is the theorem that we just covered on the last slide. Well, if this is a right angle, that would mean that these two segments are perpendicular to each other because they intersect at 90 degrees. So I can therefore say AD is perpendicular to BC because two segments that intersect at 90 degrees are perpendicular to each other. And with that, this proof is finished. Now, again, AD is a median because it intersects at 90 degrees. Further, these two triangles are congruent, meaning that BD and DC are congruent to each other by CPCTC. So since these two segments are congruent, that also means that D is a midpoint, which would make segment AD a median as well. Further, it's intersecting at 90 degrees, it's bisecting the segment, therefore it's also a perpendicular bisector. Now, this is only true for isosceles triangles when the segment is going from the vertex angle to the base. It wouldn't necessarily work if it was going from a base angle to one of the legs, unless it was an equilateral triangle. So just keep that in mind. You may be asked some always, sometimes never questions on that down the road. It's important to know that in an isosceles triangle, if your segment's going from the vertex to the base, it will not only be a median, it can also be an altitude, and it can also be a perpendicular bisector. So just keep that in mind. All right, let's go ahead and try an application problem with this. Is line A perpendicular to line B? Justify your answer. So to get started, first off, I see that these are lines, and I know that lines add to be 180 degrees. So I can add some of these angles to be 180 degrees. So I can say 2x plus 37 plus 2x plus y is equal to 180 degrees. I can do the same thing with line A. Now, of course, I'm going to go ahead and simplify this. 2x plus 2x is 4x plus y is equal to 143. From here, I'm going to go ahead and create my equation with line A, so 2x plus y plus 3y minus 21 equals 180. Again, this is just simplifying in the blue, and then in the red, we went ahead and wrote out our equation. I'm going to go ahead and simplify the red equation now. This will give us 2x plus 4y equals 201. Now, looking at this, I have two equations with two different variables in both equations, x and y. So we have a system of equations. So I'm going to go ahead and bring this equation over so that's underneath our blue equation so we can go ahead and solve. We're going to use elimination in order to solve for the variable y. So to get started, we're going to cancel out our x values. So I want my x values to have opposite coefficients. These two numbers need to be opposites of one another. So I'm going to go ahead and multiply my bottom equation by -2, and that will make it so I have opposite coefficients. So I now have 4x plus y equals 143. That's this top equation here. So just move down. And then my bottom equation has turned into -4x minus 8y equals -402. Now that my x values are opposite with their coefficients, I'm just going to combine the equations straight down. So 4x plus -4x cancels. Y plus -8y equals -7y. And 143 minus 402 will give me -259. From here, I divide both sides by -7 to get y by itself. The -7s will cancel. -259 divided by -7 will give me +37. So y is equal to +37. From here, I can go ahead and plug back into any of the two original problems and solve for x. So I'm going to go ahead and plug it into the red equation here and then solve for x from there. So this will give me 2x plus 4 times 37 equals 201. 4 times 37 will give me 141. So 2x plus 141 equals 201. Subtracting 141 from both sides, we get 2x equals 60. Lastly, dividing both sides by 2, we get x equals 30. Now at this point, if any of these angles are 90, just one of them, if one of them is 90, that's enough to say that these lines are perpendicular. If any of these are not 90, that's enough to say that they are not perpendicular. So I'm going to go ahead and plug this in. I only need to plug it into one of these equations. So I'll go ahead and plug it into this equation right here, 2x plus 37 degrees. That'll give me 2 times 30, which is 60, plus 37, which is 97 degrees. Therefore, these are not perpendicular because they do not intersect at 90 degrees. And that's it. All right, let's go ahead and move on to our bonus learning target today, which is factoring. We're going to go ahead and factor trinomials using perfect squares. So go ahead and pause the video if you'd like. These are our tips for factoring. If you need to write these down, please feel free to. Let's go ahead and start by solving by taking the square root. So to do this, first off, some unique things about this compared to the other ones that we've done in the past. This time it's not set equal to 0. It's set equal to a perfect square, meaning two numbers multiplied by each other, two whole numbers multiplied by each other will equal 64. 8 and 8, right? So that makes this a perfect square. Further, our c value is also a perfect square. 7 times 7 is 49, making 49 a perfect square. So to start off with, we always go ahead and we look for our GCF. There is no GCF between our three terms. So we're going to go ahead and multiply our a value times our c value. 1 times 49 will, of course, give us 49. From here, we're going to look for numbers that add to be -14, multiply to be +49. So we list out all of our terms, all of our factors. And -7 plus -7 will equal -14. -7 times -7 will equal 49. So these are our two terms, -7 and -7. And I know that we're on the right track if we have two of the same numbers. That's what we're looking for. So it'd be either 7 and 7 or -7 and -7. Pay attention to that sign out front here because that will tell you whether it's going to be positive or negative values. From here, we put both of our -7s inside our double bubbles. So we have x minus 7 times x minus 7 equals 64. Now, these two are the same exact thing being multiplied by each other. So therefore, I can rewrite this as x minus 7 squared equals 64. Now, to get rid of a square, we need to take the square root. So this is where the square root comes in. And the only reason that these came together is because they both had the same number here. That's the only reason I can do that. If they were different numbers, I couldn't do that. So I go ahead and I take the square root of both sides. That will make the square cancel out and leave me with x minus 7 equals plus or minus 8. Very important that we have plus or minus 8. Reason for this, positive 8 times positive 8 is 64. Negative 8 times negative 8 is 64. From here, we can set up our two equations. X minus 7 equals positive 8, and x minus 7 equals negative 8. At this point, we can go ahead and solve for x. I'll add 7 to both sides, giving me x equals 15 and x equals -1. And those are our two solutions. All right, let's go ahead and ramp up the difficulty a little bit. Next up, we have 2x squared plus 20x plus 50 equals 72. So again, we start off by looking for a GCF between all three terms on the left side. Our GCF would be 2. So I'm going to go ahead and factor out a 2. I'm going to divide each of these terms by 2. And I'm just going to have my 2 sitting on the outside of the parentheses. So this will give me 2 times x squared plus 10x plus 25 equals 72. Now again, the reason that these numbers are all here, 2x squared divided by 2 will give me x squared. 20x divided by 2 will give me 10x. 50 divided by 2 will give me 25. I didn't mess with anything on the right side of my equation, that just remained the same. From here, we find our a value and we multiply it by our c value. 1 times 25 will give us 25. Now we look for numbers that add to be 10 and multiply to be 25. So listing out all the factors of 25, I have 1 and 25, 5 and 5. Then I could do the negatives as well, but I already found my answer. 5 plus 5 is positive 10. So I go ahead and I put x plus 5 times x plus 5 in my double bubbles. It's still equal to 72, and this 2 on the outside is just hanging out. It's just going to stay there for now. It's not doing anything. It just stays on the outside. Again, I have 2 of the same thing that's being multiplied by each other, so I can condense that down into one bubble and square it. So I have 2 times x plus 5 squared equals 72. At this point, 72 is not a perfect square. The next closest perfect squares to 72 are 64 and 81. So I don't want to take the square root quite yet. What I'm going to do is I'm going to get rid of this 2. So I have 2 multiplied by x plus 5 squared. To undo multiplication, I'm going to divide both sides by 2. That will give us x plus 5 squared equals 36. From here, to get rid of the square, we take the square root of both sides, and that'll give us x plus 5 equals plus or minus 6. Now I can set up my 2 equations. And again, when I divided by 2, that gave us a perfect square, so we knew that we were on the right track. From here, I have x plus 5 equals 6, and x plus 5 equals -6. Solving for x, we get x equals 1 and x equals -11. And those are our 2 answers. Here's our final problem. Go ahead and try it out on your own. I'll be going through it shortly. All right, so looking at this, again, we start off by looking for the GCF between all three terms. Our GCF for this one, again, is 2, so I factor out a 2. That'll give me 2 times x squared minus 22 plus 121 equals 162. I take my a value, the number in front of x squared, inside the parentheses, which is 1. I multiply it by my c value, 121. That'll give me 121. So I look for numbers that add to be -22 and multiply to be 121. Those values would be -11 and -11. From here, I'm going to go ahead and put these terms inside my double bubble. 2 is still going to be on the outside. So I have 2 times x minus 11 times x minus 11 equals 162. From here, I can condense these x minus 11s down into 1, giving me 2 times x minus 11 squared equals 162. Again, 162 is not a perfect square, so I'm going to divide both sides by 2, giving me x minus 11 squared equals 81. Now, I go ahead and I take the square root to get rid of the square. This gives us x minus 11 equals plus or minus 9. We can now write our 2 equations as x minus 11 equals 9 and x minus 11 equals -9. Solving for both of these equations, we get x equals 20 and x equals positive 2. So those are our 2 final answers. All right, we've now covered both learning targets for today, a right angle theorem as well as factoring. If you guys have any questions, please let me know. Thank you guys so much for watching. I really do appreciate it. Have a great rest of your day. Thank you.